4 options.
So the group observed the current inventory area on the herring, and we noticed 3 things. First, clutter. They had bins and things that they have getting ready to store. Also, space not being utilized, and then also there was enough space, but they weren't utilizing it very well. Okay, here's a schematic of the inventory area. So it's basically 3 shelving units, 2 larger units, and then 1 small unit against the wall. The inventory consists of parts, aluminum, and steel components. And on the right, you can see that they're holding, storing, if you will, old material. They have an old machine mill, and then oil drums and just scrap metal that are just sitting, but it's taking precedence over inventory. So we use the DMAIC to come to a solution for the inventory area. And we use a root cause analysis, and we ask the 3 whys. Why? Well, of course, it's clutter, misplaced inventory, and then it was an inconsistent system. Okay, so clutter, basically they haven't sorted through things, and it's a material that you're going to use for future projects. Misplaced inventory, basically the employees are placing inventory where they can because of just the whole layout and what they're storing currently. And then the third is an inconsistent system. As new inventory is coming in, they're not arranging or updating the area, if you will. So we have come to some improvements, suggested some improvements. First is declutter. They need to sort through that old material and the old scrap metal. They need to sticker all the products so there's no misplaced inventory. They need to put like parts together. And then most importantly, they need to stack boxes vertically. It's now they're currently doing a horizontal inventory. I think this will be a more efficient system.
So, as stated before, the coolant recycling is kind of non-existent for all of the machines other than the CNCs because they have their own recycling and filtration system. So, the company purchased a 55-gallon drum of the concentrated coolant, which is then mixed with water, and it can create, I believe, 27 gallons of mixed coolant. And that will last them about a month, and one 55-gallon of concentrated coolant costs them about $1,000 per month. So that comes to $12,000 annually. The price for disposal is 40 cents per gallon. So after calculating the number of gallons of coolant that they actually have, it comes out to around $500 per month and $6,000 annually that they're spending to dispose of this coolant. So to alleviate these costs, we've come up with 2 options. One is the Smart Skim coolant loop, which would cost $16,000, and that's figure 1, and the Smart Skim sump caddy, which would cost $6,500, and that's figure 2. So after both of these options would reduce the cost of the new coolant, of purchasing new coolant by 30 to 70%, while also cutting the cost of the dirty coolant disposal by 50 to 90%. And both of the options, they're going to increase tool life because cleaner coolant running through the machines, debris in the dirty coolant are messing with the tools, they're messing with the part. So tool life is going to increase by up to 209%. So because we can't actually measure the percentage that the company's going to save until they actually start using the coolant recycling system, there's going to be a range of savings for the cost of the coolant. It's going to be between $3,600 and $8,400 annually on purchasing coolant, and for disposal, it's going to be between $3,000 and $5,400 annually for disposing of the coolant. So our recommendation is the sump caddy. we decided that because of the size of the company and the storage constraints, that the more portable option is gonna be more viable for the company. And the return on investment is gonna be much quicker than it would with the more expensive option. So in summary, our recommendations are to refurbish the existing rotary machine, so the 4 or 6 operations can be added onto that and the current machine, and reorganize the inventory area to improve the flow and prevent misplaced lost products, and also get rid of that wasted space, and purchase a coolant recycling system to save them money on cost of new coolant and the cost of disposing the old coolant. Any questions?
Trying to avoid standing next to the monitor because unconsciously you're going to be looking at the monitor. So instead, you're talking to us, and if you want to attract their attention to the screen. See what I'm saying? So when you're hiding behind the monitor, I don't see you, and you're looking at the monitor, and you're not seeing me. The text slides could be improved. The ones that they had pictures were fantastic. The ones that they had text in it, the important information was not really attracting my attention.
Okay.
So
Which
take a
ones
look at those.
Was it the size or
Yeah,
color?
for example, when you go to this one here,
Uh-huh.
you know, what's really being attention, getting my attention is the coolant recycling recommendations, and after that, nothing else, it's me.
Okay.
You see what I'm saying? Like option 1 and option 2 should be brought up, like here, you see what I'm saying, this one?
Uh-huh.
Right, okay, so I wanna take a look at those, I had to actually search for it.
Okay.
And the speed was probably the best so far. You know, you were trying to explain and you were explaining, you were rushing through it. So
But
that was-
they said you took 2.5 minutes more than what you did, so you need to work on your content for sure. That's a significant decrease, so it needs practice.
Okay.
And you need
Dr.
to
Palpini,
practice.
we can't hear you.
They can hear. No, I'm just saying
No,
that
she's taking notes.
they went with a reasonable speed, but they went over the limit, the time limit. You need to practice.
There, you have the slide on rotary layouts. I wasn't sure what the circle areas meant.
Yeah. So, the red and blue is basically the orientation, because it has to flip. So it actually goes all the way around, and once it comes back to the operator has to flip it, and then it goes back again to account for the holes on different sides of the part. And then we colorize the heads to match the part that it's actually operating on. So that's basically what the different color is. In this, it's configured like this, but in the red, it's in a different orientation to get those holes.
And then you circled some things, but
Yeah, so in this one, this is our current table. The ones that I circled are the 4 heads that we're gonna be adding to the current table.
I guess it's not clear, because, I don't know, for me at least, because, then you said that you're going to come up with the bottom right.
Yeah, so we're doing both. We're adding to the current table instead of having 6 machines on the table. The current table that they have is actually very small compared to the current one. So the engineers at Control Engineering, they said, if we can fit operations on the current rotary machine, it's gonna save space for the new machine because it has a smaller table.
I guess the slide doesn't show what you're trying to.
Okay.
I don't know, maybe an actual picture of the table,
Okay.
or maybe some
Yeah,
points.
yeah, I'll label it better.
And maybe you can talk to Dr. Wagner later